So let's review what you know. If you change the number of electrons, what do you change? Hopefully you said the charge. If you change the number of neutrons, you're going to change the mass. And if you change the number of protons, you're going to actually change elements. This is pretty hard to do. You can't just change elements very easily. Yeah, it's easy to switch out neutrons. It's easy to switch out electrons. Not so easy to throw protons and stuff out of the nucleus. So here's how we express this information about protons and neutrons and electrons. This is how we express it. So if you remember from the periodic chart, we had this number. And remember, I was saying this is called the atomic number. And I was also saying it's the same thing as the number of protons. Remember, it can't be this number because this has a decimal, and we knew that protons are whole things. You can't have part of a proton, so it's got to be that top number. On different periodic charts, you may find this 2 centered. You may find it at the bottom. You may find it at the side. Look for the thing that doesn't have a decimal. That'll tell you the number of protons. Now, funnily enough, there's a good reason for this, but even though most periodic charts will have this number above the element, it's odd when we use this kind of notation, which you will see for sure, we put it on the bottom. So this goes down there. Now mass number, that's what we talked about. That's the protons plus the neutrons. That goes up on the top. Now the reason we do it this way is so that if you need to figure out how many neutrons something has, it's really easy because the 4 is on the top, the big number's on the top, and it's like easy to subtract and say that this has 2 neutrons. Again, the 2, we already know how many protons it has. And then if there's a charge, we always write it over on the right-hand side. Now, how do you get to how many electrons are in that charge? Well, if you know that you have 2 protons, remember that means at the inside there were 2 protons and there were 2 electrons. We need, I'm sorry, that's neutrons, not electrons. 2 neutrons. We need the outside to have how many electrons? So that it has a 2 plus charge. Actually, it has 0 electrons on the outside. Yep, that's right. You're going to have 0 electrons on the outside for you to have a 2 plus charge. A second way that this is also symbolized is, like this is the same information, and this is right here, the mass number. So sometimes you'll see something like this with numbers in the different corners. Sometimes you'll see something like this. This is specifically what helps us know what isotopes we're talking about. It doesn't give us any information about if it has a charge or not. You don't have to know that there's a 2 in the corner to know the 2. Because remember, if we know that it's helium, then we always know the number of protons. It's that number that's in the same block as helium. So I'm going to give you a moment to go ahead and work through these questions right here. Before we do it, I just want to give you kind of a method if you like methods. I really recommend, if it's not obvious, always figure out the number of protons immediately. Like always try to go for that. And so, for example, all of the first section here, these are like heliums and phosphorus and silicons in here. So heliums, you get the number of protons from finding it on the chart and using the whole number. So helium, again, it's that 2 up there. So that's 2, and that's 2, because they're all helium. So that's my suggestion. Whenever possible, get that proton number in. And then, especially when it's noted like this, where it's like vertical, like these ones are, these 3 are a little trickier because they're not vertical. But whenever it's noted like that, it's so easy because you just like draw a little line and you can figure out the number of neutrons like that. You just subtract to get to the number of neutrons. So all of them had 2 protons. This one had 1 neutron. This one had 1 neutron. And then this one had 2 neutrons. That's kind of my first 2 steps I recommend. If you've got the mass number information, go ahead and get the number of neutrons because it's really easy. The place that people will sometimes mess around with is using the number of protons and the charge. So that's the last step. Sometimes you don't get the number of protons on something, but if you have the charge, you can always get to the number of protons. So right now, this means that if I draw this picture, I have 2 protons, I've got 1 neutron in the middle, and the protons are positive. How many electrons on the outside? Well, there's 2 protons. I'm going to need 1 electron for it to be this positive charge. 1 electron. Again, I've got 2 protons. I've got 1 neutron. That's my middle of my element. Now, how many electrons do I need for a negative charge? Well, I've got 2 protons. I got to have more than that to make it negative because electrons are negative. I'm going to need 3 electrons. And then over here, again, I've got the 2 protons. I've got 2 neutrons. That's in my nucleus. So outside, I'm going to need, if it's 2 plus, I'm actually have 0 electrons. So go on your own and figure out this and this, answer this, and figure out this section right here.